All right, so as our lesson gets started for you guys that are watching at home, I'm going to share my screen, and I've got 3 little warm-up questions on the topic of completing the square, and we can do with completing the square. So go ahead and go through these 3 warm-ups. I'm going to step out of the way so you guys here in class can see. And if you're at home, go ahead and pause your video, work these 3 out, and then we will pick back up in just a second. Yeah, I might try to go after it.
Morning, guys.
Morning.
I didn't talk to you about this. Okay. I've already signed, I've already turned it in.
Not yours, mine.
Yeah, I said that last time. Well, we didn't look at that stuff, she always did. Talk about it. She agreed with you. She said, I give you a lot of you. So this, she said, too. And hold on.
I'm so sorry, man. Oh. Did it make sense? Just before anybody else touches it, I'll be back. All right, I'm sorry, fellas. Y'all are being chatty, but so am I. So that's let's get to it. Thank you, Coach Smith. All right, so plugging and chugging on number 1. Ben Rouse, you got something for me? 28. Okay. Does anybody concur with that? Awesome. All right, so we got -2 squared and 4 times 3 times -2. Now look, the way that I just wrote that up, I want you to take a mental picture of how I just wrote that up. What did I use when I was plugging and chugging? Parentheses, daggum right. Later on in this lesson, probably on into Monday's lesson, you guys are in school on Monday, right? Okay, Monday's the only day that we're in school next week, so FYI, before I forget to tell you that. Anywho, we will be doing just that. B squared minus 4AC, and I'll be writing it up using parentheses like that. What'd you say it was, Ben? 28. All right, I'll take your word for it since all your classmates are agreeing with you. Now, square root of 108. How about George Booth? Tell me what I could take out of 108. How many times does 27 go in? 4 is also a perfect square. Okay, so 27, all right, our minds are going to meld here. 27 has a what in it? What's 27 divided by 3? 9 is a perfect square. So there's a 9 and there's a 4. What's 9 times 4? 36, and we had a what left over? A 3, right? Because we took our 3 out from our 27. So in other words, the 108, what I just got George to do, thank you, George, was to sort of split this guy up. He said it was 27 times 4, and I said, all right, well, 27 is 9 times 3, right? And so which of those two perfect squares, that and that? So anytime you've got a couple of perfect squares, did you know that the product of two perfect squares is itself a perfect square? I don't know if you guys knew that or not, but it is. So this is like saying 36 times 3, and the square root of 36 is 6. So this winds up being 6 square root of 3. So very good. Thank you again. Now, similarly, number 3, we would say what? What's our answer on number 3? Call it out. 5 square root of 2. Fabulous. 5 square root of 2. Those we ought to be able to do in our head. The relatively small number with an obvious perfect square factor inside it, I want you guys to be able to do it in your head just like that. Okay? Now, any questions on the warm-up? They'll all feel properly warm? Okay. So, we have in the last week or so, we've talked about the square root method and how we can use the square root method to solve equations. More recently, I have thrown to you completing the square, which is a process by which we take something that looks like what's on your screen right here, and we turn it into something that we can use the square root method on. All right. Like as I look at this right here, the first note that I make mentally is that this does not factor. So because it does not factor, I can't use the ZPP, which is a shame because I love me some ZPP action, right? Me and Alex have that in common. I don't know if you guys knew that about him. Alex, we on the weekends we work ZPP problems, don't we? Oh yeah, that's right. Not you and I together, me by myself, you by yourself, but we just, you have hobbies. Some of you guys are closet ZPP guys, aren't you? Charlie knows what I'm talking about. Oh yeah, Chuck, that a boy. But sadly, this was not a ZPP problem. Okay, so that means that I want to try to do completing the square, but we've got one small issue here, and that is that the first term is not a perfect square. So when I get into that completing the square process, like I've taught you guys to do, right? We add 1 to both sides to leave a little space, right? We leave a little blank. That's where in your previous lesson, let me scroll back up to it. Remember we had this slide right here, and these were where your blanks were, and we were like, gee, what fills in the blank? What number goes here? What number goes there? What number goes here? What number goes there? And we had that process. You cut the linear coefficient, you square it, and you add that to both sides. Well, what all 4 of these had in common was that they all had a first term that was x squared and nothing else. So when you look at this problem, and you've got that little space, before you fill that space in, brother, you better dadgum check to see how you can make this x squared. Okay, Andrew, how could I do that?
5 by 2.
Yes, we're going to divide away that quadratic coefficient. So make yourself a little note, okay? If a does not equal 1, then divide, if I could spell, both sides by a, right? So I'm going to divide by 2 in this case. Now here's where the problem becomes a little bit interesting, is that now we're dealing with a what? We're dealing with a fraction. Should we be scared? Don't be scared. Tiago's not scared. Tiago knows how to handle a fraction. Tiago, I'm going to cut it in half and ding, square it. How do I cut a fraction in half? How do I cut a fraction in half? Like, let me ignore the 7/2 for just a sec, and we're going to think about pizza. You like pizza? I freaking love pizza, right? Don't know many people that don't like pizza. My youngest child is sadly a person that doesn't like pizza, but Tiago is not my youngest child, and Tiago likes pizza. What kind of pizza are we eating, Tiago? Pepperoni pizza. You know, my favorite kind of pizza is, I like to go to the, not Fuego, Pyro. I like to go to the Pyro's Pizza. You guys ever go to the Pyro's Pizza? So we're going to get a Pyro's pepperoni pizza, okay? A little alliteration on a Friday. And Tiago, I'm sorry, son, but they only had a half a pizza for you. So here's your half a pizza. But you know what? Your buddy Paul there really likes pepperoni pizza also. So I want you to take your half of a pizza, and I want you to cut it in half. Now, how much does each person get? A quarter. So you had a 1/2, and you cut it in half, and all of a sudden you have a 1/4. All right. Now let's say we're at the pizza joint, and we've got each person gets 1 slice of a pie. Y'all know they normally cut up pizzas into 8 slices. So you got, let's say that Mossy over here has an 1/8 of a piece of pizza, and Lewis doesn't have any pizza, and Mossy's going to be nice and friendly to Lewis. He's like, dude, I'll split it with you. He cuts his in half. How do you cut an 1/8 in half? What are you left with? 1/16. Okay. So what are we doing to the denominator to cut a fraction in half? We are doubling the denominator. I like to say, you double down, okay? The way that you cut a fraction in half is you double down. You double the denominator. So 7/2, when we cut that in half, becomes 7/4. Ding! Then we square it and we get what? 49/16. And that is what we're gonna add to both sides. 49/16. Okay. Now again, I've had this with my freshies. I may have it with you guys. Some of you might be looking at this green fraction being like, what the dump? Where did that come from? Okay. Remember, the reason that is 49/16 is because we took the linear coefficient, we cut it in half, and then we squared the result. Okay, that's what we did. What was B? B was 7/2. okay? B was 7/2. So when we cut 7/2 in half, that became 7/4. 7/4 squared is 49/16. Now that left-hand side is a PST, is a perfect square trinomial, which we're going to factor out. All right, remember your baby steps. X times X. You don't have to do this step if you don't want to. 7/4 times 7/4. Circle, circle, circle. So that's going to be X plus 7/4. Quantity squared equals. Okay. Now, Quentin, what do I have it set equal to? What do I need to do over here, in other words, to figure out what this side of the equation is? Nice and loud. What do you want to do to the right-hand side in the step above? Yeah, add those two fractions, right? Drew Benton, what does it take to add two fractions? A common dead-gum denominator, all right? Now, Reed, what should my common denominator be?
16.
Good, and 1/2 is the same thing as how many sixteenths? 8/16. So I'm going to change that 1/2 to a 8/16, so that now we're going to have 57/16. How now, brown cow? And so we're set, good to go for what now? What should I do next, Lewis?
Take the square root.
Correct. Our square root method is set, sitting right up there on the T, ready for us to tee off on. Okay? So when we have a problem at the beginning that is in our standard formula, ax squared plus bx plus c equals 0, and we want to solve that, and it does not factor, okay? Then we can make it factor by scooching the constant over, dividing everything by a, and then completing the square, and then using the square root method. Everything we've done for the last week is building on top of the previous lesson, okay? Now I take the square root of both sides, and I don't want to forget my what? Plus or minus. All right, hold on, I need more space. All right, so x plus 7/4 equals plus or minus. Now, does 50, well, first of all, how do I take the square root of a fraction? Do we remember that, Jake? Yeah, very good. Square the top, square the bottom. Bottom's cake, that's gravy. 4. You make a side note at this point saying that the denominator will always work out nice and neat. If the denominator is not a perfect square already, then you've done something wrong. You messed up now, Ron. Okay? So that 16, it's not a coincidence that that is a perfect square. We dadgum made it a perfect square. Look up there in green. Remember where green came from was where I took something, cut it in half, and then squared it. So it's going to always work out. Second side note, okay, I just to maintain similar forms here, I'm going to write my 7/4, 7 right on top of 4. Hey, look, these two denominators will always be the same. So a second side note, that's a little check. If these two denominators are not the same, you done messed up now, okay? We made a mistake. So not only should that first denominator over here on the right side, should this be a, everything worked out nice and neat, it should also match the other denominator. But we want to simplify the numerator. All right, so Nate, thinking back to our warm-up questions where we had things like the square root of 108, or we had the square root of 50, right? We're looking for a perfect square factor. What goes into 57? 3 times. Correct. Are either of those perfect squares? Actually, those are both prime numbers, so can I do anything with square root of 57? No, I cannot. And that's okay. Jack McBee, what's our last step? Bring it on home. Good, and where should we put that? Should we put it at the end or at the beginning? Good, so we're going to say -7 plus or minus square root of 57 all over 4. Notice I went ahead and combined the two fractions together because they had the same denominator. So instead of writing it as Instead of saying -7/4 plus or minus square root of 57/4, instead of leaving it separate, we need to put them together. All right, so look at what we've just achieved. In a matter of steps, with this first example, we have taken something that originally did not factor, and we have still solved it. Now, this is a pretty ugly looking answer, right? It's not long gone are the days where all of our answers are like x equals 2, x equals -5, and we're all happy and everything's great, right? Okay, we're in big boy school now. We're wearing our big boy pants, and we can deal with big, fat, ugly, irrational answers that look like this, okay? Any questions on that process? Coach, how'd you get from this step to this step? Or where did that come from? Any questions? Joe, you have a question? Now, people back in the day when they were developing techniques for solving quadratic equations, they did hundreds of these. They probably did thousands of these, right? And they got to where they were like, you know what? We keep doing the same things over and over again, right? We keep moving the constant over and dividing both sides by a if a is there. And then we cut this thing in half and square, and we magically add that to both sides, so that shows up. And then we're always combining these two things, right? What are these two things? Remember, we had said, yeah, we turned c into a fraction, and we combine, and then we're always taking the square root of both sides, so that radical shows up. And anyway, so they did hundreds and hundreds of these, and then they realized this can be what's called automated. You guys know what automation is, right? So automation is when you have something that you repeatedly do over and over and over and over and over again. You're like, gosh, dog, I could probably program a computer to do this, right? Or a robot or a machine to do this for me. And it could probably do it a lot faster and a lot more efficiently. So this process became automated. Now, generally speaking, this is what we're dealing with. We've got ax squared plus bx plus c equals 0. You need to buckle up because it's about to get bumpy. All right. So here's how this process shakes out. We always move c over first. So we subtract both sides by c. I'm about to do the exact same thing we did in the previous example, except instead of with numbers, we're going to do it with letters. Okay, hence the bumpy ride. Next step we said was to do what to both sides? Divide everything by a. So we got x squared plus b over a x equals -c over a. All right. Make sure you guys are keeping up. So we have moved c over. We have divided everything by a. Now we're going to complete the square. We're going to fill in that blank. And remember, what we do is we take the linear coefficient, which at this point is, what's your linear coefficient at this point? B over a. Coefficient means number in front of x. So b over a, we're going to cut it in half and ding, square it. Except it's a fraction. So how do you cut a fraction in half? Hey, you double down. All right, so we're going to b over 2a. We're going to b over 2a. Now, a little side note, b over 2a quantity squared. It's always nice to use the margin of your paper, right, to figure stuff out. b over 2a times b over 2a becomes b squared over 4a squared, because remember, you got to square the 2 and the a. That's, I'll put it in green again. That's what we're going to add right here. B squared over 4a squared. Goes on the left. Goes on the right. Actually, you know what I'd like to do? Just so it'll look nice later. Let me put it first. So I'm going to move. We'll shift that around. All right. So we now have a perfect square trinomial on the left. Okay. So how does that factor out? As a binomial times itself. And remember, x is the first one. And what do you think might be, Will Edwards, you got any idea? What do you think might go right here? All right. Let's go back then to that page earlier. Hold on. Oh, there it is. All right, so going back to that page earlier. Do you remember how we, of course, we filled in the blanks by cut it in half and square it, ding, cut it in half, square it, ding, cut it in half, square it, ding, cut it in half, square it, ding. Look at what went in the blank each time. It was just this cut in half, this cut in half, this cut in half, this cut in half. That's what went in the blank each time. And then the signage of that first term, right? So keep that in mind because I'm coming back to you, Will. So what do you think should go in the blank right there? Can we cut this in half? The whole fraction. So b squared over I pointed at the green thing. I apologize. I meant to point right here. B over 2a. It's b over 2a. All right, and then we're going to use that same sign of plus right there. Now, look, if you feel like, gosh, dog, that's confusing, do the baby step, right? What baby step am I talking about? Where we split each term, b over 2a, b over 2a. And what do I do? Circle, circle, circle. That's why the baby step is there. In case, and I'm not saying you are babies, I'm saying it's a small, teeny, tiny, itty bitty little step in case you need it to help you fill in the blank. So x plus b over 2a. And then here's where we, I think Quentin told us and Drew did it for us. We need to do what with those two terms? We need to combine them together. And to combine them together, it takes a common denominator. Now, what's missing? Let me zoom in. What's missing from this denominator's fraction that you would like to put in there? A 4 and an a. You're missing a 4 and an a. Well, guess what? I'm going to put a 4a on top, and I'm going to put a 4a on bottom. Bada bing, bada boom. Now we got our same denominators, don't we? Okay. So this left-hand side becomes b squared minus 4ac all over 4a squared. Y'all don't mind getting out a little bit late, do you? I got like maybe 1 or 2 minutes left. Okay. But what we just did was we changed that second fraction, and then we are putting them together. And did you remember your two side notes earlier? What was the first side note? Side note, we said if this denominator is not a perfect square, you done messed up now. Is this a perfect square? Yes. Good. So when we take the square root of both sides, as Lewis told us to do in the last example, we now have x plus b over 2a equals what? Plus or dadgum minus. Don't you dare forget it. Joey, you looked like you were going to forget it. Got my eye on you there, boy. We got a plus or minus. Now, the square root of the top is what it is. And then what about the bottom? What was that second side note? The denominators are going to be the same. So those two side notes come together to make sure, hey, 4a squared is a perfect square, and 2a is what that denominator now is that I've taken the square root of both sides. And since I've now got the same denominator, in my last step here to subtract b over 2a, I got negative b over 2a plus or minus that square root over 2a, so I can slap it all together. All over 2a. And this is what is known as the what? This is the quadratic formula, which helps us solve all quadratic equations. And you guys just derived it. Okay? Told you it was going to be a bumpy ride. We ran through that pretty quickly. Am I going to ask you to derive that on your own? No. Am I going to ask you to memorize this? Yes. So, you need to have it written down with a big fat box around it saying, memorize this formula. And once that's the case, once you have that down in your notes, you can skedaddle on out of here. Thank you guys for a wonderful week. Come Monday, we will work some problems using the quadratic formula. Okie dokie, artichoke. Thank you guys if you're watching at home. And all of us live Jesus in our hearts forever.